So we find the tangent of A minus B, and then we reciprocate. So now we go to our formulas, and hopefully you have a nice sheet of formulas there that you're getting used to. Once again, hopefully you have transferred a sheet that you can use in regards to when it comes test time. We have tangent A minus B, tangent A minus tangent B over 1 plus tangent A times the tangent of B. So we need to find this value first. So what we're looking for here is we had to find what is our tangent of A and what is our tangent of B. So write down your tangent of A, write down your tangent of B. Tangent of A, what do we have for the tangent A, Maddie? And tangent of B? 5/12. Now we have 3 over negative 4. 3 over negative 4. When you have the negative on the bottom, what I suggest you do, you can move that negative out to the front or up top. Does not matter. You can move it out front, or if you want to, you can move it up top here and have a negative 3 over 4. Even though it's 3 over negative 4, the negative could go either spot. Does not matter. If I have 10 divided by negative 2, I get negative 5. If I have negative 10 divided by 2, I still get negative 5. So it doesn't matter where that negative goes. On the bottom, we have negative 3 over 4 again, which is tangent of A, and then we have our 5 over 12. So if we take a look, what this, I would simplify these bottom two multiplications here. Leave the top as it is to begin with. Negative 3 over 4 minus 5 over 12. And then on the bottom we have 1 plus. Well, we're multiplying two fractions together. How we multiply our two fractions together? Multiply the tops, multiply the bottoms. So we have negative 15 over 48. Okay, all we're doing is we're doing mathematical fractional mathematics here. Okay, things you dealt with back in 5th grade, 6th grade when you started dealing with fractions. You learn how to add, subtract, multiply, and divide fractions.
Yeah. I have a question for the bottom. Since 4 goes into 12, can you just multiply that by 3 and leave it?
Yes. What I'm going to do is I'm going to leave it like this right now. You could do other type of simplifications, and that's fine. But it may be easier not to simplify those fractions before you can take the 3 and the 12 and cancel to give you the value of something over 16. But what may be helpful for us is just leave it as 48 for right now. Okay, because if we look at our next step is we have to simplify a complex fraction. Now, once again, this goes back to what you did some stuff in algebra, but now we just deal with the mathematics of the numbers here. We have a complex fraction. Okay, there's two ways of being able to deal with this. The first way is enhancing your mathematical skills and deal with this as a complex fraction. The other way is to be able to just go into your calculator and click to your calculator. And we'll go through that in a second. We have a big fraction here where this is our numerator and this is our denominator. And within the big fractions, we have a bunch of little fractions, I call them. We got small fractions here, small fractions here. But when I have a numerator and denominator, the properties of mathematics and properties of fractions is you can multiply numerator and denominator by the exact same thing without changing the fractions. We can make equivalent fractions. You can also divide. We multiply and divide anything to numerator and denominator and create equivalent fractions. Well, if we take a look at this, we have 4, 12, and 48. We want to find a common denominator. A common denominator between 4, 12, and 28. Or I'm sorry, 48. 4, 12, and 48. What would be our common denominator here? What would be a common denominator between 4, 12, and 48? 48. That's why, Maddie, I said let's leave it as 48, because what you have down here, and we're going to multiply everything, numerator and denominator, by this value of 48. Once again, we are creating equivalent fractions. So we have 48 times 3/4. Now, if I look, my 4 and 48 will cancel down to 1. This would give me a 1, and this would give me a 12 up here. So I have -3 times 12, which is -36. In the second one, this would cancel 1 and 4, so I have 4 times 5. So we have -36 minus 20. This will cancel, giving 4 times 5 to give us 20. On the bottom, we have 48 minus 15. Multiplying our 48 to all of our terms on the bottom. So what we're left with is -56 over 33. This here is your tangent of A minus B. What we want is we want our cotangent, so we just flip it over then. So we have 33 over -56 is your cotangent of A minus B. And once again, you can throw that negative out front or on top. Now, your calculator is a very nice tool. If you don't want to go through the complex fractions here and worry about complex fractions, what you can also do into your calculator is quantify. Quantify -3 divided by 4 minus 5 divided by 12. And your parentheses divided by quantity, 1 minus 15 divided by 48. Okay, we can quickly collect that into our calculator. Don't hit enter yet. So we have -3. Make sure you divide by, or use the negative sign. Get your parenthesis in there. -3 divided by 4. Minus 5 divided by 12. End your parenthesis. Bless you. Divide this by 1 plus a -15 divided by 48. Quantity 1 plus -15 divided by 48. Or you can also write it as minus. Okay, do not hit your enter sign yet. Does anybody have problems getting that typed in? Okay, now, above your X and negative or below your green button. Below your green button, you have a math button. Hit that math button. Below the green button, hit your math button. We want our first option. What this does is this takes our answer and moves it back into a fraction. So you hit enter, and then you hit enter one more time. And Alikababa Shishkumba, poof. Magically, our answer comes out for us. KYC, know your calculator. If you want to enhance your math skills and really work at this, you go over here. If you want to just get through the problem and manage through the mathematics of the problem, you go with that. And that's fine. I don't want a decimal. Don't want a decimal. Take it back into a fraction form. So hit your math button, hit enter, and it takes you right there. That is a nice feature to have because whenever you want to reduce your fractions down, say you have 45 divided by 63, and you want to reduce that fraction down, you can hit your math button, hit your math button, hit enter, and it reduces your fraction down for you. It's a nice little tool to have. Calculator does nice things for you. Let's take a look at problem number 9. We want to solve for our two general solutions. We have the tangent of 2 theta minus tangent of 50 over 1 plus tangent 2 theta times the tangent of 50, and that's equal to negative square root of 3. Once again, what you're looking at is all the right-hand side of your formulas that you have written down, hopefully. All the right-hand sides of your formula. Which one looks like what we have there? Tangent minus tangent over 1 plus tangent times tangent. Okay, when we're dealing with tangents, it's sort of nice because it's either going to be tangent A plus B or tangent A minus B. Zach, what do we have? Tangent A minus B. So here's your A, here's your B. Here's your A, here's your B. So what we could do, you're taking it from the right and moving it back to the left. So this just turns into tangent of 2 theta minus 50 equal negative square root of 3. So you're just trying to take what we have here and put it into an equation that we can now solve. Because in the form that we have up there, we can't solve that equation. But when we have it in this form, we can now solve this equation because I have the tangent of 2 theta minus 50 equals negative square root of 3. We want to solve for theta, 2 general solutions. McLean, how do we get rid of the tangent? Inverse tangent. The inverse tangent of the tangent will get rid of these. So we are left with 2 theta minus 50 is equal to the inverse tangent of negative square root of 3. So now I can clickety-clack, do my calculator, Inverse tangent of negative square root of 3. Make sure you use the negative sign, not the minus sign on the right, negative sign at the bottom. So when you take the inverse tangent of negative square root of 3, Kendall, what do you come up with? Negative 60? Good with that? All right. Now, when we deal with the inverse sine, you have the principal value in the supplement. When we deal with the inverse cosine, we have our principal value and its opposite. Okay, and that's what you had to utilize in the other 4 problems on the back side here. Okay, because you had to take the inverse sine and inverse cosine. Well, we never gone through inverse tangent. When we take the inverse tangent, what do we have to worry about? Do we have to worry about a second value? We got our calculator value, which we call our principal value. When you deal with the inverse tangent, though, you don't have to worry about a second value. You just have to worry about this value here. We'll talk about how we get other values, though, in a minute. So we have 2 theta minus 50 equals negative 60. We solve the equation for theta. So we can add our 50 over and divide by 2. So we should have negative 5 plus or minus the period end. Question is, how do we come up with the period? Well, if we take a look at our tangent, when we look at our tangent, we have sine over cosine. So what we have to graph for our tangent, our guide for our tangent, going back to graphs of sines and cosines, our tangent and cotangents, we have to graph our cosine. So if we graph our cosine, we start at our peak, (360°) we're at our peak, 180 we are at our valley, and we cross our prime axis here. Wherever we crossed our prime axis, we had our vertical asymptotes. Then when we look at our graph, tangent was upper right to lower left. Well, if I take a look at another asymptote in here, we would have that at negative 90. And this is our graph of our tangents. Now going back to definitions. Period is defined to us with our graphs of sine and cosine as the number of degrees in the cycle. Well, the definition of a cycle was a portion of the graph to another portion of the graph where the graph starts to repeat itself. Well, if I take a look at tangent and cotangent, I go from negative 90 to, or I'm going from 90 to 270. How many degrees do we have for one complete cycle here? Do we go 360 degrees for one complete cycle? What do we have for one complete cycle here? We go from negative 90 to 90. We go from 90 to 270. Each one of those This just starts to repeat itself. This is a repeat of this. The number of degrees we have, 180. So the period for tangent, when we had sine and cosine, the period was 360 divided by b. When I talk about tangent and cotangent, the period is going to be 180 divided by our b value. Bless you. Well, our b value is a value of 2. So the period is going to be 180 divided by 2, or 90. So if you look at my solutions and you want to deal with the solutions, if you went through this problem, you looked at a solution, you said, well, how did I get 90 degrees rather than 180 because our b value was 2? And this is the reason why. Any other questions you have? This worksheet I sort of call a review for the review sheet. Because the review sheet that you're going to see tomorrow is going to look very similar to this. The quiz that you will see on Thursday will look very similar to this. It will not be as many angle addition formulas at the bottom. It will not be as many equations on the back. Okay? But I did give a couple trig identities there. Sorry. I put through a couple trig identities in there for you to work on too. Once again, need to push yourself. I know it's springtime. I know the weather's getting nice out. I get it. But you need to continue to force yourself and push yourself to do your educational responsibilities. Solutions are posted. Also have a set of solutions up here for you, printed out. You have about 10 minutes here. The rest of the time is yours to work on these. It's a challenge at this time of the year. We've got to the end of having fun with classes and school, but we still have to be able to handle and get through material. So that's a challenge for you.